Picture a factory floor in 1974, humming with machines, workers juggling dozens of jobs, each waiting impatiently for its turn. Kenneth R. Baker steps into this chaos with a simple question. How do you decide which job runs first to keep everything humming smoothly? The answer isn't just a checklist. It's a hidden strategy that transforms confusion into flow. But the real challenge: when every job demands different machines, timing, and resources, sequencing becomes a puzzle that's alive and dynamic. Imagine one machine, several independent jobs lined up. How do you avoid costly downtime and missed deadlines? It's the classic problem Kenneth Baker breaks down where every decision counts. Baker highlights Smith's rule, a method from the 1950s where jobs are sequenced by shortest processing time first. Picture a 1950s machine shop in Michigan. Instead of tackling the biggest jobs, the operators knock out the quick ones first. This simple trick slashes the average wait time, speeding up the whole workflow. Think of scheduling like a busy barista's morning rush. Each coffee request is a job, and the machine is the espresso maker. If the barista handles the quickest orders first, more customers leave satisfied early on. This analogy reveals how sequencing isn't just math. It's about managing real-world pressures with clear, practical rules. Here's the kicker. Tweaking just one sequence can cascade into monumental efficiency improvements, cutting idle time, lowering costs, and boosting morale. Baker shows us that good sequencing turns chaos into rhythm, proving small, smart moves reshape entire operations. Now multiply that by several machines working in parallel. How do you sequence jobs that bounce from one machine to another without turning the floor into a traffic jam? Baker walks us into an automotive plant in Detroit, where multiple machines operate simultaneously. Jobs hop between stations with strict order. Here, improper sequencing turns one machine idle and the next overloaded. Sound familiar? Leveraging parallel machine models helped engineers predict and prevent these gridlocks before they happened. Picture a highway with several toll booths, each a machine. If too many cars queue at one booth while others idle, traffic snarls. Bottlenecks throttle the flow. Balanced sequencing distributes workload evenly, like traffic cops directing cars efficiently through all lanes. This analogy uncovers the core mechanism behind parallel machine scheduling. When managers grasp balance and bottleneck dynamics, they unlock agility that propels entire projects. Baker demonstrates how this sequencing freedom translates into fewer delays, better resource use, and ultimately happier customers who get their cars or jobs faster. Beyond machines, what if you juggle entire projects constrained by limited resources and strict deadlines? This is where Baker's network methods take the stage, trading chaos for clarity. In a sprawling aerospace project detailed by Baker, hundreds of interdependent tasks form a massive tangled web. Using network diagrams, project managers chart each task's dependencies, turning confusion into a navigable map. It's like charting routes through a complex city, where every detour changes your arrival time. The critical path is the project's heartbeat, the longest chain of dependent tasks that dictates minimum completion time. Baker likens it to a relay race where a single slow runner delays the whole team. Identifying this path lets managers focus on what truly matters, slicing away slack and cutting delays. Resource constraints often force rescheduling, as manpower, materials, or machines become limiting factors. Here, Baker's resource-constrained scheduling shows the power of flexible adaptation, like reshuffling players mid-game to win. The payoff is a dynamic plan that responds to real-world limits, yet still drives projects to timely finish lines. Back on that noisy factory floor from the start, we now see the rhythms hiding beneath the noise. Baker's lessons reveal that sequencing and scheduling aren't abstract puzzles. They're practical tools that transform daily grind into smooth performance. Next time you face a tangle of tasks or competing demands, try mapping out dependencies or tackling shortest jobs first. You'll find order where you least expected it. Subscribe for more book summaries like this one.